Hello, I'm Richard with EV4U Custom Conversions, and welcome to another episode of EV Basics. Previously we talked about where to start your conversion, and in the last episode we talked about the vehicle. In this episode we're going to talk about motors and controllers. And really what we need to consider when we talk about motor and controller is the vehicle weight. That is really a bottom line determiner on that decision. It might also be that you want a certain amount of performance, you want to do some street racing or something. But in this series, EV Basics, we're talking about commuter cars and the basic rules of thumb. So with the exception of a high performance setup and so forth, what we're going to be talking about is what's appropriate for a given commuter vehicle. And so let's talk about the weight of a vehicle and how that affects a motor choice. Well, here's the kind of the rule when we're talking about the series wound DC motors like the Warp 9. Typically, if you have a vehicle that's under 2,000 pounds, you can get away with an 8-inch motor. If your vehicle weighs between 2,000 and 3,000 pounds, you're going to want to choose a 9-inch motor. In between 3,000 and 4,000 pounds, an 11-inch motor. Now, as this all comes together, you'll see some of the big picture. But just as another little information piece, when you're designing the voltage of your pack, remember volts equals speed and amps equals torque. And as we've mentioned before, if you want a freeway capable vehicle, you're basically going to want a 120 volt and better pack. So a 200 volt pack will power your vehicle faster than a 120 volt pack. That is if your motor controller can handle that. And so let's talk about the motors and controllers. Probably the most popular motor out there is the Netgain Warp 9. It's a 9 1/4 inch motor. And it's 16 inches in length. And it's 165 pounds. And the specs that Netgain gives us are at 72 volts. And that's where, when you're doing your homework and you're investigating some of this stuff, it gets a little sticky, because they don't all rate them at the same voltage or at any other common denominator. And so you kind of have to look at their curves. And let me show you what that looked like. You can find the graphs that will give you all the information regarding voltage and current and horsepower and torque and RPMs. Will help you make a decision on what's best for your vehicle. So at 72 volts, the Warp 9 puts out 30 horsepower. And 60 foot-pounds of torque. And it does that at 307 amps at 2,233 RPMs. And it's a 5,000 maximum RPM motor. And they run $2,000 approximately. So you look at that and you say 30 horsepower, 60 foot-pounds of torque. I mean, that's less than a VW Bug stock. Well, here's the additional piece of that picture. This is actual figures that's been tested on a dyno. And again, you could go in between this anywhere, but at 192 volts and 1,000 amps, this little old Warp 9 will crank out 157 horsepower and 277 foot-pounds of torque. So, like I said, it's a little bit of homework to kind of get to where you're looking at apples and apples. But this is your Warp 9. Let's take a look at the Warp 11, which would be appropriate if you had a little heavier vehicle in the 3,000 to 4,000 pound range. And the Warp 11 is 11.5 inches approximately. I think it's 11.45 to be exact, but 11.5 inches. And it's 17 inches in length. And this isn't including the shaft. These length inches are just the case, the body of the motor. It doesn't include the shafts. And you can have single shaft or double shaft, which would affect the overall length. And the weight is 229 pounds. It's going to be the heaviest one we're going to talk about today. Again, net gain spec, 72 volts, and the horsepower is 44. The torque is 135. You can see the torque's quite a bit more. The larger the diameter, the greater the torque. It's all about leverage. Rules of physics always apply. And that was at 453 amps and 1,442 RPMs. So it's cranking it out at lower RPMs, but it's pulling a little more amps. And again, that's a 5,000 RPM maximum motor. And they run about $3,000. Now, one thing about this, again, like I said, not the most impressive numbers because we're at a very low voltage. But this will put out at 1,000 amps I'm sorry I don't have the voltage figure on this, but at 1,000 amps it'll put out 290 foot-pounds of torque. I don't have the voltage written down, so I'm sorry. So you can see these readings right here would have to be with a 1,000 amp controller, of course. And we're going to be getting to that in a few minutes. Next, let's talk about an AC choice. Used to be, going back a few years, there weren't a lot of choices when it came to AC conversions. But today, thanks to high-performance electric vehicle systems, we have quite a few. It's where you have to start looking at the specs to make decisions. So there's other DC motor manufacturers other than NetGain. That's just the one that I prefer. And like I said, the Warp 9 is probably the most common in a conversion. So a popular AC setup would be the AC 50, which is good. I think they say up to like 3,500 pounds. I would say more like 2,600 pounds, but we'll connect it here with you know, here, here, here. And the AC50 is an 8-inch diameter motor. So you can see it's a little different than we were given the rule of thumb for the DC. Again, that's just rough. This works real good for, you know, vehicles in the, you know, 2,000 to 2,600 pound realm. It's 14 inches in length. So, you know, depending on your space limitations, you can see how this could work out well because it's smaller than the Warp 9. And it's only 115 pounds. So that's a plus too. And then the spec voltage on this one is 140 volts. In the past, we've typically used a different controller with this that was only good up to 130 volts. This one actually, we're rated at 140, but it's good up to, I think Curtis calls it 144 volt. But it's good up to like 170 volts. The 1238-7601, we've actually run 133 volts through them lots of times, no problem. But anyway, this is just the spec volts because that's what we're going to get these numbers from. And so, a 140 volt setup is going to put out 87 horsepower and 86 foot-pounds of torque at 523 amps. And at 5,500 RPMs. So you can see the AC is a little higher RPM setup, and their maximum RPMs on that motor is rated at 6,000. And the cost is about $4,600. But at $4,600 includes the controller. So these prices with the net gain, that's just the motor. The price for the AC50 includes the 144 volt Curtis controller. All right. One more that I wanted to just show you for demonstration purposes here, and that is the AC75. And if you're following our videos, the AC75 is what we used in the Volkswagen Transporter. It's a 9-inch diameter, 16 inches long, so it's real close in dimensions to the Warp 9, and it's 180 pounds. And they don't give you a hole for a lifting hook like NetGain does, which is something that I've always, you know, grumbled about. But anyway, and again, this one, these specs are going to come out at 144 volts. And so at 144 volts, this thing's putting out 92 horsepower and 124 foot-pounds of torque at 538 amps. and 4,000 RPMs. And again, its max is 6,000, and it's a $5,700 price tag. But again, that includes the controller. So I'm trying to go over this rather quickly so that the video is not too long. But I just wanted to give you a little picture of some of the things that you'll be wanting to look at. Is the motor going to physically fit in my vehicle? Is weight going to be a consideration for that particular vehicle? You can see big difference here on the weight of the motor. And remember, the weight will affect your range in the big picture. So another spec that we got from High Performance Electric Vehicles on the AC75, and that is at 96 volts. This was at 144 at 96 volts. This thing's putting out 79 horsepower, so we're getting less horsepower. But this is with the Curtis 650 amp controller. So it's putting out greater amps. Remember, amps equals torque, 183 foot-pounds of torque. So this one was a 500 amp controller. This is a 650 amp controller. Alrighty, let's talk about controllers. With the lighter vehicle, with either one of these, and if you are on level ground, you know, you're not pulling a lot of hills, and you have a lighter vehicle, and it's a lighter duty use, a good controller is the Curtis 1231C-8601. Very common one. We've used in a lot of conversions. It's 500 amps, and it's air cooled. And so I think it's a 96 volt to 144 volt, and that's nominal. Because we run 156 to 160 volts through them without a problem. But that's the nominal voltage rating. The downside of the Curtis is that because it's air cooled, it has limited ability to dissipate heat. And heat, of course, is an enemy. And so this 500 amps can only be delivered for 2 minutes. And it'll deliver 375 amps for 5 minutes. And it'll deliver 225 amps for 1 hour. So I would consider that pretty much continuous. If you've got a car that's going to drive continuous for 1 hour, pulling 500 amps, you got a pretty good sized pack. Anyway, the other, kind of a plus side to the Curtis is they're around $1,500. You can get them a little bit less sometimes, but that's the neighborhood. Well, The limitation there is, like I discussed, so the next step up, and to get the performance that we talked about earlier, you're going to need to go to a liquid-cooled controller. And what we use is the Soliton by Evnetics. And they make two. They make a Soliton Junior, which is 500 amps. But the difference is between the 500 amps of the Curtis and the 500 amps of the Soliton Junior is that it will deliver 500 amps continuously. And it has a lot of other features that we're not going to go into for this discussion. This is kind of a bare bones, plain Jane, plug and play kind of setup. This is top of the line, fancy, best DC controller you can get. It's the Evnetics controllers. So that's 500 amps continuous, and they're about $2,000. But they're liquid cooled, so you also have the additional cost of your liquid cooling setup. And then, we mentioned earlier, you have the Soliton 1. And that's 1,000 amp continuous. Liquid cooled, about a $3,000 price tag. But these two are good to 340 volts. They're a continuous rating. And the Soliton 1, in combination with your Warp 9, puts you at $5,000. So you're between the two AC setups, the AC50 and AC75, as far as cost. And they both would need liquid cooling added to those prices. But what you're going to get with this setup is you're going to get the torque of a series wound DC motor. And so you're going to get the ability to run 192 volts and 1,000 amps. And this little Warp 9 will put out 157 horsepower and 277 foot-pounds of torque, which is an impressive little ride. You put that in a Porsche or a light vehicle, and you're going to have a lot of fun. But those are the things you need to look at in order to make a decision of what motor controller combination is going to be best for what you have. What's going to work best for the size of vehicle and the intended use of that vehicle. I mean, if you're going to use a minivan for commuting and it weighs 3,500 pounds empty, that's its curb weight, and then you're going to haul 3 or 4 of your buddies to work every day, well, you've just upped the bottom line on the weight by maybe 600 to 800 pounds. So you need to consider the bottom line there in making these decisions. So that's just kind of didn't want to make it too in-depth, keep the video short, but it's hard to do because we just barely scratched the surface as far as motors and controllers and those considerations go. But we just wanted to kind of give you a little overview and feel for that big picture. Here's 4 motor options, kind of what their specs look like, cost, and capability. And so, in our next episode, we're going to talk about the battery pack size. We want to be able to size our battery pack to match again with our motor and controller considerations, and the pack size all have to be considered together. And the real determiner and all that, again, goes back to that vehicle weight that we talked about previously. And so we hope you'll stay with us and join us next time for battery pack considerations, and we'll see you then. Hello, I'm Richard with EV4U Custom Conversions. You want to learn more? You want to learn about all the components in greater detail? You want to actually install the components and wire a conversion? Test it and drive it? Well, you can. By attending one of EV4U's 3-day hands-on conversion workshops. You will get a chance to learn, discuss, ask questions about all the components used in a conversion. Wiring techniques, hardware used, safety, how it all goes together, and much more. But we don't just talk about it. We go into the shop and install the components in a vehicle, wire it up, and test it. After testing in the shop, we test it on our test track and in the industrial park where we're located. One of the vehicles we'll be using in 2014 is our Sandrail. It's a blast. So come join us for 3 days of education and fun. Meet people from all over in a beautiful setting while learning how to convert a vehicle from gas to electric. EV4U provides lunch each day at great local restaurants. After hours, you can visit many of the local attractions, like Shasta Lake, the largest lake in California, Shasta Dam, the second largest concrete dam in the United States, Shasta Caverns. You can take a dinner cruise on Shasta Lake, take a walk on the Sundial Bridge, visit Mount Shasta. There's night skiing available during the winter. Visit Burney Falls National Recreation Area, or go kayaking at Whiskeytown Lake. You can check out the source of the Sacramento River. Sacramento River is the largest river in the state of California, and you can see where it bubbles out of the ground. We've got world-class fishing, hiking, and biking, all within minutes of EV4U's shop. So we hope you'll join us. So visit www.ev4unow.com and register today. The class sizes are limited, so don't delay.